Welcome to Signal Processing Laboratory. In this video, we are going to see the seventh experiment, realization of the FIR Weiner filter. So the Weiner filter is used to produce an estimate of the desired or target random process by linear time invariant filtering of an observed noisy process. So we are using the linear time invariant filtering here with an assumption that the stationary signal and the noise spectra and additive noise are known. So we are using linear time invariant filtering with an assuming that we have already know the stationary signal, noise spectra and the additive noise. So the Weiner filter minimizes the mean square error between the estimated random process and the desired process. So it will minimize the mean square error between the estimated process and the desired process. So the main goal of this Weiner filter is to compute the statistical estimate of an unknown signal using a related signal as an input and filtering that known signal to produce the estimate as an output. So the main goal here, we are going to compute the statistical estimate of an unknown signal, but we are using the related known signal as an input and filtering it that known signal we can produce the estimate signal. For example, the known signal might consist of an unknown signal of interest that has been corrupted by the additive noise. So here the known signal may have an unknown signal of interest because they have been corrupted by the additive noise signal. So the Weiner filter can be used to filter out the noise from the corrupted signal to provide an estimate of the underlying signal of interest. So we are using this filter to find out the to filter out the noise from the corrupted signal and to provide an estimate of the underlying the original signal or the signal of interest. So the Weiner filter is based on statistical approach, and most statistical account of theory is given by the minimum mean square error. So it is a statistical approach. So Weiner filter is based on the statistical approach. So the design of Weiner filter takes a different approach. One is assumed to have knowledge of the spectral properties of the original signal and the noise, and one seeks the linear time invariant filter whose output would come as close to the original signal as possible. So while designing the Weiner filter, so it will take a different approach. The one is it is assumed to have a knowledge of the spectral properties of original signal and the noise. So one should have the it is assumed that one must have the knowledge of the spectral properties of the original signal and the noise signal, and one seeks the linear time invariant filter whose output would come as close to the original signal as possible. So when we use the linear time invariant filter, so the output must be as close to the original signal as possible. So this is the program for FIR Weiner filter. So let's execute the program. So this is the desired signal and the signal corrupted with noise. So here the estimated signal is as close as possible to the original signal or the desired signal, and this is the error signal. So we are filtering out this error signal from the signal corrupted with noise. Okay, so we will see the next experiment in the next video. Thank you.